Okay, stats, let's do some 4.2. Talks about on page 1 in 4.2 to review a bit about lines and their equations. Remember that a line is an equation y equals mx plus b, where m is the slope and b is the y-intercept. There's a completed copy of the 4.2 notes online, and you can use it to fill out example 1. Just as a reminder, the slope on number 1 at the bottom is 0.1, and the intercept is 29.9, and what that means is for the U-Haul truck, it costs 29.9 baseline, and then an additional 10 cents for miles driven. That's what slope interprets as. What we really need to talk about, though, is the least squares regression line. So now if we make a scatter diagram, very rarely are they all going to line up in a perfect line to where a line connects all of them. But we have what's called the least squares regression line, which is basically the line of best fit. If you're trying to draw a line that comes as close to the points as possible, like minimizes the amount of distance away from the line they are, it's called the least squares regression line, or the line of best fit. Now, what are the criteria? It's technically to minimize the distance to the line, the vertical distance. Now, don't worry so much about what the equation says on there, because we're not going to calculate these by hand. Primarily, we're just going to calculate them using the calculators, so you can ignore the formulas on page 2 and just know that the least squares regression line in your calculator is going to be y equals ax plus b. And if you've learned in your calculator how to find where to find the r value, like how to calculate it, then you'll notice that there's an a and a b right next to the r in your calculator, and those are the a and the b for your line. So what does that mean? Well, it means that your calculator is pretty much going to do all of the work for you. All you have to do is make sure you enter the data in correctly. Okay, so let's go back to the problem from 4.1 where we had the hours of study and exam grade, because we found that those had a large R value, so you know that it's a reliable data, so that there should be a linear relationship. So to find the least squares regression line, you're just going to put the data back in for L1 and L2, and it's going to spit out your y equals ax plus b. I did it online, and I sent out a Canvas email giving you the link to the one that I recommend using if you're going to put it in online for your homework. And when you put the data in, it gives you the formula that y equals, I'm going to round to 2 decimal places, 5.49 plus 50.97. I'm like, okay, 5.49x, excuse me, plus 50.97. And we'll talk about what that means as we move down. That means that based on the number of hours studied, you should be able to predict the score over here to the left. So it says predict the score of someone studying 6 hours. It's really just asking you to plug in 6 for whatever hours is, which should be x. So y equals 5.49 times 6 plus 50.97. Again, you can put that into the calculator. 5.49 times 6 plus 50.97 is 83.91. It's about an 84. Because you can't really get an 83.91 on a test, but that's really close to 84. So if you're actually getting a test grade, you'd probably say they expect an 84, not an 83.91. Now, how does that compare to the person who actually studied 6 hours in the table? The person who studied 6 hours, the actual person got an 82. We expected what? An 84. So it's higher by a little, but it's close. So we expected an 84, they only actually got an 82, so they did slightly below average compared to what we expected. Now, the question of how much does each hour of study increase performance? So what do these numbers mean is important in the equation. This really means that if you study 0 hours, that means 5.49 times 0 is 0. That means you're expected to get about a 51. But for every hour after that, your grade increases about 5.5 points. So each hour roughly increases your score by 5.49 points, so about 5.5. That's the slope. So how much does something increase? Each unit increase something is your slope. How you're gonna do if you don't do any studying at all, that's your y-intercept. Now, there's a little blurb on page 4 about whether or not, at the very bottom of page 4, you cannot use this to predict ridiculous things. Like, I can't predict that if you study 100 hours, that you're going to get about a 600 on the test, because that's not realistic. So there's like a limit to where you can apply the least squares regression line. You need to use some sense on when you can apply it or not. And we'll talk more about that in the next video when we do another problem. And that's all for now.